Good day, learner. I am Ademola Oyetunji, a physics teacher from Osun State, southwest part of Nigeria. Good afternoon. Have you ever wondered what is the difference between the sound wave and the light wave? The difference between the sound wave and the light wave is in the classification of the wave into either mechanical wave or electromagnetic wave. The sound wave, as we all know, is a longitudinal wave. The longitudinal wave in the sense that the direction of traveling of the wave is parallel to the direction of propagation of the wave. In that case, the longitudinal wave now set up a region of high pressure in the air and low pressure in the air, causing what we call the compression and the rarefaction. The compression and this rarefaction constitute the waveform that look like the crest and the trough that we explain when we are considering the general wave form. Let me now take you through this. In this video, we are going to show you the relationship between the velocity of sound, the wavelength, and the frequency as they are relating with each other. In this video also, we are going to work examples and determine the factors that can affect the speed of sound in air. Here we go. The learning outcome of this video, by the end of this video, you should be able to 1. Derive an equation for the velocity of sound. 2. Solve simple problem on the speed of sound. And 3. Explain factors that affect the speed of sound. The speed of sound, like every other speed, is defined as the time rate of distance traveled by the wave particles. Its unit is meter per second, like the rectilinear speed that we talk about. Let me now explain this. Speed is defined as the distance all over time taken, but the distance in this case is the distance that a particle wave when it completes one oscillation or circle, and that distance is called the wavelength, and we define that one as the distance between two successful compression or rarefaction, which is the wavelength of a longitudinal wave. Also, the time taken for a wave to complete one circle or oscillation is the period. Whereas, if you are to determine the speed, which is the distance all over time taken, in the concept of this longitudinal wave, the speed is equal to wavelength all over period. But the period is related to frequency by the numbers of circles that a wave completes in 1 second is called the frequency, and the frequency is the reciprocal of the period. So by the time we now put that one, you are going to see that velocity is the product of frequency and the wavelength, which we represent by V is equal to F lambda. Working example. A source of sound of frequency 500 Hz emits waves of wavelength 60 meters in air. What is the velocity of the what? Of the sound in air? We are given the frequency, we are given the wavelength. The frequency is 550 Hz and the wavelength is 60 meters. We are to calculate the velocity of sound in air, which is not given. From the relation that we just did, self-assessment. Deduce an equation for the speed of sound. Mention 2 factors affecting the speed of sound in air. The wavelength of sound travel with a velocity of 360 meters per second, 66 meters. What is the period of the sound wave? 1 minute. Conclusion. Velocity of sound is equal to wavelength all over period. It's like distance all over time. Frequency is 1 all over period. F is 1 all over t. So V is equal to F lambda. Sound travel fastest in the solid like metal, slowest in the gas like air. Temperature affect the velocity of sound in air, and direction of wind affect the speed of